the adapter here. So, who among you here are interested into agriculture or into farming? Okay, that's too many. Thank you, guys. So that's good. So, I was introduced earlier as a software engineer and who loves farming and who loves to tinker things. So I'm going to discuss about my way into the smart farming field. So this is my background. This is what I did in college. I literally cook soil. So on the bottom part, on the bottom left and the upper left, I was conducting a soil analysis. And on the topmost and the rightmost portion of that slide, I was doing a research on making a device that can detect the quality of steel or rebars once it is embedded in a concrete. So it is still an ongoing research. And this one as well. I was planning to develop a rover that can be used in civil engineering. So, how did I get involved in Smart Farm? First, of course, my love for agriculture. And I'd like to show you my home garden. It's not yet aquaponics during this time, but it's 100% organic. And my love for aquaculture. That is literally growing fish. So this one is my koi pond. I have like 1,500 kois right now. And I had 1,000 heads of tilapia. And my brother cooked them all, fortunately. So one day I got invited to build a proof of concept of a food computer. I will discuss what food computer is all about. So, one guy just sent me an email and, hey, are you interested in building a proof of concept for a project like this? And I had a schedule, I had a flight to Manila. I'm from Iligan, by the way. So I had a flight to Manila. And the component that they sent will arrive a day after my flight. So I had to contact the guys from Baguio City to just lend me some hardware so that I can build a proof of concept along the way. So that was quite difficult to manage because when I went to Sagada, there's no internet connection. There's not even, it's difficult to get a signal. So what is Food Computer all about? It is actually a project, an open source project that is initiated by MIT called Open Agriculture. So they want to build a farm that is in a box or in a container. So if you're going to Google that one, you can read all about the project. And basically what they have in mind is that if, for example, a vegetable tastes better in Baguio City than in Cagayan de Oro, then they want to replicate the climate condition or the planting condition in that particular area. So it's just basically replicating the planting condition, like the carbon dioxide, the temperature, the air quality and humidity, and almost everything. They want to replicate it. So they have what is called climate recipe. So it's just basically a text file of with a specific time and particular sensor to be enabled or disabled so that your food computer can replicate the climate of a certain area. So they call that one recipe. So I'm going to talk about the project, the one that I was involved in. It is still a food computer. It is still based on open agriculture. Basically, we have the same project, but then what they have when we were looking at their codes, what they have is that all their beta codes were deprecated, and all of the previous works that they had, they discarded it and they want to build a new one. And then since my project is to build a commercial version, and the open source version don't support that one, so our decision was to build it from scratch. So one of the main challenges is that it should have no monitor or display. So it's difficult to configure your device to connect to the Wi-Fi or connect to the server. The reason for that is the company wanted to minimize the cost, and it should have lots of pins, or I mean the hardware should have lots of pins so that the sensors and actuators can be connected to it. So our solution is to use Raspberry Pi Zero. It only costs $5. It has 40 GPIO pins, and we use Arduino Mega to handle the sensor and actuators. So we let the Raspberry Pi and Arduino Mega communicate via the serial port. And one challenge that I encounter is that the serial port of Raspberry Pi Zero, you cannot use it, and it's being used by another program, so you have to disable it and then configure it to work for the GPIO. So this is my setup. And to resolve the problem of having no display and how to enter the API key or the computer key for the device, we imitated Chromecast. So Chromecast, basically, if it's not yet connected to the internet, just plug it in. You can connect to it, open your browser, and set up. So we basically did the same thing. I configured the Raspberry Pi. I know if you can read it. I configured the Raspberry Pi in such a way that when it cannot detect or it cannot connect to the server, or it doesn't have an internet connection, it will convert itself into an access point where your laptop can connect to it, and then you just open a certain URL and you'll be looking at a setup or a setup screen where you can enter your SSID and your password, including your farm ID and your computer ID. So that way your computer or food computer can connect to the network or to the server. So this is my underlying architecture. Those that are colored blue are Arduino Mega, and then the green one is a Raspberry Pi Zero, and those small cubes or small squares are just actuators and sensors. So basically, the Arduino Mega communicates with the sensors and with the actuators, and those sensors are like air temperature and humidity. We have pH sensor. We have water temperature and other important sensors. And for the actuators, we have motors, we have fans, we even have pump. So the Mega and the Zero communicates via the serial port. And on the Raspberry Pi Zero, I use Flask and SQLite because it's lightweight, and the Raspberry Pi Zero is just very small. And on the server side, this one here, I use Django for the back end, and I also use Postgres and MongoDB. So all those relational data are stored into Postgres, and all those logs, sensor data, actuator data, and other logs, I stored it in MongoDB. So we had a hybrid setup. So as a summary for the hardware, I use Raspberry Pi Zero because it's cheap, Arduino Mega, sensors and other actuators. And for its setup, since there's no monitor or display, so we use the Raspberry to be an access point. And the Arduino Raspberry communicates via serial port, and Arduino handles everything from sensor to actuators. And Raspberry communicates with the server and Arduino. So for the server setup, I mentioned about Django, Postgres, MongoDB, and I also use Nginx for the web server. I don't know if you had a problem with Apache, but I had a problem with Apache. And with my previous company, we also used Django and Apache, and the problem was when we reached a certain amount of traffic, we cannot scale the Apache server anymore. So we had to scale the hardware or the server itself. So I prefer Nginx for web server. So what's next after that? Actually, after building the proof of concept, I quit the company and built my own startup. So I became the competitor, but not the same idea. I'm currently founding RD Farm. It's a modular aquaponics system. So if you're not familiar with aquaponics, it's just growing food out of water. So that's without soil. And since it's aquaponics, from the word aqua itself, so you're growing fish and vegetables. So this is a setup with high-scale aquaponics. As you can see, you have to build the grow bed. This one is called the grow bed, and also this one. It has pebbles. This one is a floating raft. So the whole vegetable garden is actually floating on water. It will be removed from the fish pond and transported to the filter via pump. So from the filter, the bacteria or the microbes will eat or will convert those ammonia into nitrogen, potassium, and other essential nutrients for the plants. And those converted nutrients, those actually are dangerous or toxic for the fish, but it is helpful and it is essential for the plant. So the plants get those nutrients, and then in return it filters the water, remove those toxic elements, and the water is clean when it goes back to the fish pond. So this is my setup. Since my problem when I work with aquaponics is that it costs a lot of money to build, and you need to have the skill in plumbing, carpentry to build your own. I don't know if a lot of you or some of you are engaging into aquaponics, but that's the problem I encountered. So I designed something that is modular. So everything is a module. You have a filter module, you have a grow bucket module. So you can look at the arrow. This one is a grow bucket module. It has 4 conduit, so you just plug and play and everything will work. And on top of it, since I wanted it to be smart, is a computer or a core computer, and it communicates via this server. So currently it's on proof of concept, and last year, we won the Mindanao Startup Challenge that was hosted in MSU IIT. So we are currently being incubated for like 2 months. And last January, some of the guys from Cebu actually are here. They're here, and we went to Cebu to present a project, and this was the Maker Conference being hosted by DTI. So currently my project or my prototype was sponsored by Fab Lab Mindanao. I'm going to plug Fab Lab since I'm connected with them. It is inside MSU IIT, and it is being funded by DTI and DOST. And it's open to all. We have a CNC machine, laser cutter. We have 3D printer and other essential stuff for building a prototype. And also, that prototype of mine was sponsored by IDEA. It's a technology business incubator of MHYIT. So if you have an idea, you can present, and yeah, you'll be incubated, and they will help you bootstrap your project from idea into a startup. So that was a short talk, and if you want, or if you want to reach me, you can just send me an email. Thank you, guys.